Good afternoon. Welcome to the AutoPilot DIG220 webinar. I'd just like to make a couple introductions before we get started. My name is Brad Manning. I'll be your presenter. And we have Matthew Gamolka. He's going to be fielding any of the questions that you guys may have to ask during the presentation. At this time, I'd like to ask you to use the question and answer bar for any questions that you may have. We have AutoPilot training seminars for the next 5 weeks after this one, for a total of 7. The next webinar will be on the total control on June the 2nd at 3 p.m. The one after that will be on the co-pilot, June the 9th at 3 p.m. Soft touch on the 16th at 9 a.m. Pool pilot professional on the 23rd at 3 p.m. ORP on the 30th at 3 p.m. Water chemistry, July the 7th at 3 p.m. Along with these webinars, we have factory tech support. We have a direct hotline at 727-456-7426 for any of the questions you may have for troubleshooting, installation, so on and so forth. We also have, on top of that, we have YouTube videos on how-tos, how to convert Nano Plus to from 110 to 220 or vice versa. Same thing with the AutoPilot, just instructional videos. This is our DIG220 and manifold. DIG220 features: maintains pools up to 80,000 gallons, vacuum fluorescent display, optional relay provided to run a pool pump. If you'd like to run a pool pump with the DIG220, I would suggest that if it's a brand new order and you know you're going to run the pool pump, that you can order the DIG220 RI, which the RI stands for relay included. But if you make a mistake and just order a DIG220 because you don't know that it's going to be running the pool pump, you can order a separate relay at no charge, and it comes with installation instructions. We'll be going over that a little bit later on in the presentation. It's got a purifier output up to 2.62 pounds per day and patented temperature compensation. Let me touch base on that just a little bit. Temperature compensation, very simply put, as the water temperature rises, the system will increase the percentage of output on the chlorinator. As the temperature falls or drops, it will decrease the amount of percentage on the AutoPilot. It's got a 24 and 72 hour boost cycle. On a 24 or 72 hour boost, what the system does is no matter what percentage you have the DIG220 set at, it will automatically raise it up to 100% output for 24 hours or 72 hours. For a 72 hour boost, you have to press and hold the boost button down for about 7 to 10 seconds, and you will see it say super boost, and then it'll have boost 72 instead of boost 24. It has a quick reference guide right there in front. You pull down the door and it's got some troubleshooting instructions, so on and so forth. It operates at salt levels between 2,000 to 35,000 parts per million. We actually have our system on ocean water pools that are at 35,000 parts per million salt. We actually do not have a high cutoff on the salt. I've actually tested the systems all the way up to 80,000 parts per million. They work beautifully. We do, however, have a low cutoff at 1,900 parts per million salt reading. The system will stop chlorine production. Operates at temperatures up to 104. It will actually operate higher than 104 because we are, after all, heat sources. But we know in the pool industry that 104, no body of water should exceed 104. We have what's called a soft reverse. That's a cleaning cycle. The systems leave the factory set for a reverse time of 4 hours. That reverse time can actually be set to 2 hours, 4 hours, 8 hours, and 16 hours. And then we have 5 different cells that can be put on the DIG220 to customize it to the pool that you're desiring to chlorinate. I've got a question Go ahead, Matthew.
So Brad, Sherilyn, one of our customers or attendees asked a very good question about the boost feature. And she was asking if the boost will override the pre-programmed timers for the pool pump if the relay, if you're controlling the pump with the autopilot.
Yeah, I would have. Excellent question. I would have got to that when we got to the actual wiring but yes, to answer the question, that when the DIG220 is controlling the pool pump, if you press the boost button and put it into a boost cycle, it overrides any time clock settings that you have in the autopilot. So it will run the pump for a complete 24 hours. And then whatever time the boost stops, if it's in the middle of the normal pump run time, the pump will continue to run till it's time for it to shut off.
Very good. Thank you.
Mm-hmm.
Brad, we had another question too. Edwin is asking, how does that influence the time or the life expectancy of the cell? And I believe Edwin is asking, by using the boost feature, does that affect the life expectancy of the cell?
Yes. All right. Another good question. Life expectancy of the cell, and I get this a lot as far as to how long can you expect a cell life to last, so on and so forth. Cell is kind of like a battery. The longer and harder you use it, the faster it's going to wear out. So by running a boost cycle, because you're now keeping the cell on for 24 hours straight, it will shorten the lifespan. Not so much as, boost doesn't wear any more life off of it than if you were to take the system and put it at 100% output for 24 hours. But because you're running it for 24 hours straight, if your normal time cycle is 8 hours a day, then you've utilized the cell for 16 more hours in that one day than you normally do. So yes, it will shorten the lifespan of the cell.
Okay, and to clarify that same question, Edwin added a little bit of another part to it. He means the the inverse time. I think he's talking about the reverse time. So let's ask the question this way. Does changing the reversal time, which comes preset from the factory at 4 hours, does that affect the lifespan or the life expectancy of the cell?
Yes. If the more the system reverses, the more wear it puts on the cell blades. I will tell you, the reversals are there for cleaning cleaning actions to keep the cell clean of scale. So it's far better to have a cell reverse more often. So if you're in hard water situations, I'd rather the cell reverse more often and wear life off that way than get scaled up. Scale is the worst thing you could do for cell life.
Good, and we cover this later in further slides too.
Yeah, we get it a little bit more in depth to it a little bit later on, which is why I kind of left off with just a brief overview of that.
Perfect, thank you.
Not a problem. So back to our additional features, we have our bypass manifold, and we'll talk in depth about that as well. Controlled flow rate because of the bypass manifold, easy installation. You can upgrade to the CoPilot, which is our ozone, ozone is 200 times the oxidizer that chlorine is. So it's an excellent addition to any salt system.
And that will be one of our upcoming seminars. We cover that more in depth as well.
That is correct. This is our patented manifold. It slows the water going down through our system so we can actually reach breakpoint chlorination inside of the cell. What does breakpoint chlorination do? Breakpoint chlorination actually breaks down the chloramines that are in the water. So by slowing the water down, we're actually allowing the cell to treat the water for the chloramines. The flow rates through our manifold, our flow switch only requires 15 to 20 gallons per minute to operate. The manifold can only handle 70 gallons per minute because it's the bottom of it's 2-inch plumbing. It's got dedicated salt sensor, and it will actually calculate the salt based upon the gallons that you program into the system to tell you how many pounds of salt to add to the pool to get it back up to 3,000 parts per million. Now you're going to hear me talk about this a lot as far as salts and parts per million and what our system can handle. What I need you to understand is the more salt you have in the water, the more efficient our system will operate. So all of our numbers are based upon 3,000 parts per million, but you can actually get the system to perform better by keeping more salt in the pool. This is our patented manifold. We have the check valve on the bottom. It does have flow direction labels on it. You know, I have had the bottom manifold plumbed in backwards, unfortunately, but there are flow labels on it to tell you that how to plumb it so the water flow is coming in the right side of it. We've got a debris screen to protect the cell to keep the ruthenium from getting scratched. We have a tri-sensor. It's called a tri-sensor because it senses three things: water flow, water temperature, and salt level. We have the cell, and you see the arrows. It says install with the pins facing up. You know, that cell will fit in that manifold either upside down or upright. If you place it upside down, the cell cord is going to plug up onto those prongs, and then when it rains, the water from the rain is going to run into the cell cord and could cause the cell cord to corrode up. So when you have the cell cord properly plugging down onto the prongs onto the cell cord acts like an umbrella, and you don't have to worry about getting the connectors inside the cell cord wet and causing corrosion. Manifold placement. The manifold should be placed downstream of all pool equipment, and if it's a pool spa split, it should be on the pool return line only, unless it is an ORP system such as our total control system. If you're not reading how much chlorine, you don't want the going on before the pool spa split, because when they isolate the spa, you'll have a great tendency to overchlorinate the spa. And once again, be mindful of water flow directions. If your pump has the capability of exceeding 70 gallons per minute, and with variable speed pumps, especially when they prime up at the highest RPMs that pump's designed for, or it runs on the higher RPMs, there's a great chance that it can exceed 70 gallons per minute. So this is a secondary bypass installation where we use 5-pound check valves. You can use ball valves or, the Jandy two-way valves or whatever there if you want. I kind of like no handles because you put a handle on something, the homeowner likes to turn it. With a 5-pound check valve, that 5-pound check valve is greater than our 3-pound check valve that's in our manifold. So anything that's less than 5 pounds will be diverted up towards our manifold, and anything that hits the check valve that's in our manifold will divert water up to the upper part of the manifold and through the cell. This is our tri-sensor. It has a 12-foot cord on it. And you see there on the slide with it, our simulator. That's our tri-sensor simulator. Part number is 986-ST. That simulator will be used for any erroneous salt readings, check flow messages, or erroneous temp messages. So we'll learn how to use that later on as we get into the troubleshooting portion of this. Remember, that is a 12-foot cord. So, when you're installing the system, I highly recommend that you install the manifold first before you hang the power supply, because if you hang the power supply 13 feet away from the manifold, guess what? You're going to have to special order a longer tri-sensor with a 24-foot cord and a longer cell cord. Yeah, that's also made in a 24-foot, and it's a special order. This is a side profile cutaway of our tri-sensor. This is what's up inside the T from the tri-sensor. We've got our flow sensor. Water pressure pushes the flow paddle against the post, completes the flow circuit. We have dedicated salt prongs. We're not like other systems out there. We do not base our salt reading off the conductivity of the cell. Other systems out there, when the cell starts to get scaled up or starts to deplete, it starts telling the homeowner to add salt. Our system doesn't do that. We have 2 salt prongs that are dedicated to reading the salt. And then we have our temp sensor. Our temperature is not only used for temperature compensation, but it's also used in the salt equation. So we're actually a little bit more accurate than a lot of the other salt readings out there via your handheld battery readers, your salt strips, or the Myronels that are back at the retail stores. We take water temperature into the equation of factoring out salt in the water. And then we have our alignment tab that is on our tri-sensor. The alignment tab is to always be pointed in the direction of the flow of the water. That way, if you ever have to replace a tri-sensor, you know exactly what direction to install it up into the T or in the manifold. This is the cell cord, once again, 12 foot in length. It does have the RCA jacks or banana plugs that are red and black color coded. And then if you notice, you got 3 plug holes onto the plug that plugs down onto the cell. And that's because we do have cells that not only have 2 prongs to plug the cell cord down onto, but 3. Now, just know that if you have a 2-prong cell, this cell cord fits down on a 2-prong cell. The one hole that's not used doesn't matter because it doesn't have anything making an electrical connection. So it doesn't matter which 2 of those 3 holes you use on a 2-prong cell. These are our cells. We have a PPC 1, 2, 3, 4, and 5. They all fit into our patented manifold. Now, I will say on a AutoPilot Professional that has our manifold, they're stackable cells, so they do have different unions and don't fit in this manifold. But as far as all of our residential cells and even our commercial CC cell, it can be manufactured with 2 unions on the top of it, top and bottom, to fit into our manifold. PVC body, titanium blades, and ruthenium oxide coating. This is our max chlorine output chart. The PPC1 on a DIG220 with the unit running at 100% output and a 24-hour pump run time will yield just over 1.25 gallons or 1.25 pounds of chlorine. I want to make this note right here now. You will hear me switch back and forth between pound and gallon when it comes to chlorine, because basically 1 gallon of liquid chlorine is equivalent to 1 pound of granular chlorine. They both do the same kind of work. So you might hear me switch back and forth talking about chlorine, pound, gallon, gallon, pound. It's all the same. The PPC2 at 8 amps or cell power level 3 will yield just over 1 4/10 gallon of chlorine per day. Once again, 24-hour pump run time and 100% output. All of these poundages are based upon 24-hour pump run time and 100% output in cell power level 3. A PPC3, just over 1.5 gallons or 1.5 pounds. PPC4, just under 2 pounds. And a PPC5, just over 2.5 pounds. This is the DIG220 power supply after you remove the cover. Not pictured here is the 833 board or the digital display board that's on the back of the cover. All right, this is where you'd make your connections with your incoming power. You have the terminal strip down at the bottom. You have the power fuse that's right above that. So, if you have a 220 unit, it's a 3 amp fuse. A 110 unit, it's a 6 amp fuse. Up top above that, you have a 20 amp cell fuse. You have 2 12-volt fans. You have a display fuse. And then you have the cell power transformer. And then pump relay. As I said, the pump relay is not in the normal DIG220. It is, however, in the DIG220 RI, which RI stands for relay included. And once again, you can get that relay if you order a DIG220 without it and realize you need it. You can order the relay at no charge. And wiring the unit up, bringing your income power. If it's a standalone unit that's not going to run the pool pump, you very simply bring your 3 wires in, your ground wire, and then your 2 line wires from the breaker box, and they go in terminals 1 and 2. When I talk about the terminal strip, if you look at the picture up on the top left, you've got from left to right 1, 2, 3, 4, 5, and 6 terminals there, and you have upper and lower. The incoming power goes in the bottom of 1 and 2. As you can see, there's wires that are coming out of the top of 1 and 2. They go to the noise filter. Also, you can see pictured there's the blue and brown wires that go to the relay. And we'll touch base on that when I get into the relay installation slide. So that's a DIG220 that is nothing more than a purifier. It's not going to run a pool pump. Here's the relay installation kit slide. And as I said, now you can see where the blue and brown wires go. The installation kit comes with a little sheet of paper that tells you exactly how to install it. It takes probably less than 5 minutes. I do want to make note here real quick. If you see the round transformer right here, there's a screw right in the center of it. Sometimes this transformer in shipment can slide down a little bit. So if the relay's not in here, this transformer can slide down. All you need to do to make room for this relay is loosen this screw, push the transformer up, and then tighten the screw back down. DIG220 now running a 1-speed pump. Unlike before, when it was a standalone, we had you bring the powers into the bottom of 1 and 2. Now you're going to bring the power from the breaker box into 3 and 4, and then you're going to utilize 2 little jumper wires, one to go from 4 over to 2, and another one to go from 3 over to 1. Now I will tell you, sticking 2 wires up in the bottom of these little bitty terminals can get kind of difficult the thicker the wire gets. So a lot of times what I tell you to do is, instead of running jumpers and trying to stuff 2 wires up in this one and 2 wires up in this one, is just run 4 little individual wires, a wire coming out of the 1 down, another wire coming out of 2 down, another coming out of 3 down, and another coming out of 4 down. And then what you can do is wire nut 1, 3, and then your incoming wire together. Then you can take the 2 wires from 2 and 4 and wire nut them to the incoming power here. And then once again, you have your ground wire. Then you would take your pool pump wires and bring them into 5 and 6. And your ground wire from the pump would go to the ground lug underneath the terminal bar down here. 2-speed pump application, a little bit different. This has the relay pictured because now you got to change the wires on the relay. Once again, you'd still do the same setup as far as bringing power into the unit and being sure that the relay gets power. But you'd need to make a difference on the relay over here. You would have to pull the blue wire that normally goes to position 1 on the bottom of the relay. You have to pull it and strip it and jump it from 4 over to 6. So 6 is always getting constant power. It's your common. And then you would take your brown wire. You would take the blue wire that used to be in the top of 6, and you would wire to, you would pull the spade off of number 2 here, move the spade connector up here, strip the wire back, and bring your low speed and attach it to this blue wire. Or you'd have to put a spade connector on your low speed wire coming from the pool pump and plug it onto the relay right here. Once again, you have your bonding or your grounding lugs, not bonding, but grounding. Also, I need to make note that when the DIG220 is running a 2-speed pump, there is no low speed cutoff. Your pump program times that you'll program into the unit, and there are 2 pump programs. I forgot to mention that earlier. If you're running a pool pump with the AutoPilot has the capability of turning the pump on and off twice in a 24-hour period. In a 2-speed pump application, the pump program times that you program in run the high speed. Whenever the pump, like if you run the pump from 8 to 4, it's going to run the pump on high speed from 8 to 4. And between 4 o'clock in the afternoon till 8 o'clock the next morning, the pump is running in low speed. So there is no low speed cutoff. Conversion. The DIG220 leaves the factory set up for 220 volts. If you get to a job site and you realize you only have 110 volts, it's a very simple conversion. Right here on the power module, beside all the multicolored wires that come off of the transformer, right here beside that, there's 4 spade connectors going from top to bottom. I'll label them 1, 2, 3, 4. For a close-up view of this, that's this down here. When it leaves the factory set up for 220, there's a little jumper wire that is on spade 2 and spade 3. There's a white lit jumper wire that comes inside your installation pack. So if you need to convert it from 220 to 110, you very simply move the black wire off of spade 2, move it up to spade 1. So now you have the original black jumper wire on 1 and 3. Then you take the white jumper wire that comes in your installation pack and you put it on spades 2 and 4. And then you also have to remember, I showed you a little fuse that's right there above the terminal strip. You have to change that sorry about that. You have to change that fuse out from a 3 amp fuse to a 6 amp fuse. Half the voltage means the system's going to draw twice the amperage. So if you accidentally leave this 3 amp fuse in here, as soon as the cell kicks on to energize, it's going to blow that 3 amp fuse. The connections underneath the DIG220, you have your bonding lug. It's very important that you bond all the pool equipment out. The other things you have your cell cord connections. As I told you, they're color coded. It doesn't really matter. You could plug the black into the red and the red into the black. The system's still going to work the same. You have your tri-sensor connections, and then you have our ORP dry contact. If this is on a commercial application, you can actually wire our system up to the ORP controller using a what's called a 315-AC flow cable. And just let me remind you, that is dry contact. This is not ever meant to take high voltage. So if you have one of those chemistry controllers that is only designed to run a 115 volt Stenner pump, you can't wire our system directly to that. You can purchase what's called our 110 ORP relay kit, and that'll convert it to where it has a dry contact and will run the DIG220. Menus. When you press the menu button, the first thing that pops up is Test Pool Pilot. From there, if you're not in there to do Test Pool Pilot, you can use the up or down arrow to toggle through the menu modes. It doesn't matter whether you use up or down, eventually you will get to whatever menu you're looking for. Once you get to that menu, you press select and then you can enter into that menu. So for Test Pool Pilot, if you select Test Pool Pilot, the first thing the system's going to read is the salt. Then if it's below 3,000, it's going to tell you how much salt to add. And this happens at 2,900. So in the Test Pool Pilot menu, or running a Test Pool Pilot on the system, it will actually tell you how much salt to add if you're at 2,900, because it's below the 3,000 we want the system to operate at minimally. It also has temperature. Then it gives you the cell voltage and amperage, and then amp hours. Let me explain this about amp hours. Amp hours are not the hours that the cell is run. It's the hours that the cell is run times the amps that you're applying to it. So, if you got the system set at cell power level 1, which is 5 amps, and the system runs for 1 hour, the amp hours are going to equal 5 amp hours. 2 hours of the cell running is going to equal 10 amp hours. View setup. View setup is just a way for you to check and see exactly how the unit's been programmed. There's some stuff in there that you'll probably never, like version software and any of that, but it'll tell you what the cell type is programmed for, power level, pump configuration, pool size, reverse time, time adjustment, salt adjustment, or I'm sorry, temp adjustment or salt adjustment. This is if you've ever used the unit in maintenance menu or through factory menu and did a salt adjustment to calibrate salt or temperature. Pump program 1 and pump program 2 and freeze protect. Now, one thing I want to mention, these menus are menu specific. So in other words, if you program the system that it's not running a pool pump, you will not see pump program 1 or 2. Because if it's programmed where it's not running a pool pump, these aren't options for you. But in owner options, you got select language, select units, temperature unit, 24-hour or 12-hour clock. That's military time or regular standard time. Set time of day, pump program 1 and 2. Maintenance menu is going to have a little bit more than owner options because, as the maintenance person, you should have a little bit more control of the unit. You got test pool pilot, set time of day, pump program 1 and 2 if it's running the pool pump, force reverse, set reverse time, replace cell. Now on replace cell, I want you to know this, that, if you are replacing the cell and you want to zero out the amp hours, you come to maintenance menu, get to replace cell and press and hold the select button down till the system glitches out and says amp hours 0. Calibrate temperature and calibrate salt. Now in maintenance menu, I want you to know that calibrating temperature is limited to 6 degrees up and 6 degrees down. Once you've used them, they are gone. All right. Same thing with salt calibration. Salt calibration in the maintenance menu has a limit. You can calibrate up 1,000. You can calibrate down 1,000. But once you use the 1,000 that's in the down, it's gone. Once you use 1,000 that's in the up, it's gone. Unless we walk you through, this thing is changing when I don't want it to, unless we walk you through how to use factory menu to reset those. And you have to have a simulator with you to do that. Installer menu, all right. First thing I need to mention about the installer menu is when you press the menu button and you toggle up and see installer menu, if that's what you're looking to select, to get into the installer menu, you have to press and hold the select button down for roughly somewhere around 13 to 15 seconds. Basically what you need to do is press and hold the select button down till you see the screen glitch, and then it'll say installer menu select language. Once you see the installer menu select language, you can let up off of the select button and you're now in the installer menu. And once again, when you're in a menu mode, you can use the up or down arrow to get to what you want. It's just a matter of where it's at in the menu as to whether or not it takes you longer to get to it. So in the installer menu, you got select language, select units. Units is English or metric. So liters, liters per gram or grams per liter or parts per million is what that changes. Temperature unit, that's Celsius or Fahrenheit, 12-hour, 24-hour clock. Set pool volume. Let me explain this. Set pool volume. The pool volume is only used to calculate the amount of salt you need to add to the pool to get it back up to 3,000. It's not like the system looks at how many gallons you got programmed there and says to itself, hey, I'm on a 50,000 gallon pool. I need to generate X amount of chlorine. It's only used to calculate salt. Set your cell type, because we do have 5 different cell types. Set your cell power, because the DIG220 does have 3 different power levels, 1, 2, and 3. And set pump control. This is where you go in and set it for whether it's, you got an external timer, whether you got a 1-speed pump or a 2-speed pump. Also in the installer menu, set time of day, select remote. That's if you're going to wire to automation. We don't even promote that anymore, so you don't even really hear me talk about it. It used to be that we promoted the fact that you could wire our systems to a Pentair, Jandy. Hayward wasn't out with automation back then, but anyway, and you would have to go to this to select remote 1, 2, or whatever it was wired to. Select minerals. This is just simply either salt or, if you're at a day spa or whatever and they don't want it to read salt, they want it to read minerals, you can change it to read minerals, but it's still all the same thing. It's adding salt. Once again, pump program 1 and 2 if you're running the pool pump with the AutoPilot, and enable demo. Troubleshooting. On the DIG220, the memory and programming is all held on the display board. So, if the unit won't hold program settings like the time or pump controller, stuff like that, or if you calibrate the unit on salt or temperature and it won't hold it, it goes back, you need to be looking at replacing the display board. Troubleshooting check flow message. On troubleshooting a check flow message, you want to check your normal things: pump cavitating, pump basket full, skimmer baskets full, weir stuck, pressure up on the filtration. Once you've determined that none of those things are to do with the check flow message, you would use the 986-ST, which is the tri-sensor simulator. You would plug it into the bottom of the unit, and almost instantaneously, the check flow message should go away. If you plug the tri-sensor simulator in, the check flow message doesn't go away, then it means you have a problem with the power supply. You now need to start troubleshooting the power supply. And for a DIG220, a check flow message with the simulator in means you've either got a bad 833 board or a bad wiring harness. If you plug it in and the message goes away, now it's time for you to start troubleshooting outside the power supply. Check the union screen. Check and make sure that your check valve in the bottom manifold is working. The industry is moving towards variable speed pump and 2-speed pump applications. It's very imperative that that check valve in the bottom of our manifold is opening and closing properly. If it's stuck, then you're going to get a check flow message when you're running on the lower RPMs or the 1-speed or low speed on a 2-speed pump. You also want to check to make sure the cells aren't scaled up. If a cell's got a bunch of calcium buildup in it, it will definitely impede the water through our upper manifold, which will cause a check flow message. If you inspect our check valve in the bottom, there is a clear sight glass, so you can actually see that the plunger on the check valve open and close via the pool pump. So, if you're getting a check flow message, you want to check that the check valve is working properly, turn the pump off and make sure that plunger closes. If the plunger in the check valve doesn't close, it means it's stuck in the open position. So you need to open up the manifold, wrap a piece of plastic around the union screen, close the manifold back up, and then bump the pump up onto the highest RPMs or up onto high speed if it's a 2-speed pump. Hopefully, with full water flow going through this check valve in the bottom, it will blow whatever debris may have that check valve stuck out here in the open field, and it'll allow it to close when the pump shuts off. If that doesn't happen, however, you're going to need to replace that bottom manifold, because on variable speed pumps and 2-speed pump applications, we are definitely going to have to work on the lower RPMs or low speed on a 2-speed pump. I highly recommend when plumbing this manifold in that you put unions on each side of the manifold, right up to the manifold. That way you don't have to measure anything for cutting and replacing one. You can very simply glue 2 new union pieces on each side, remove the old one and slap the new one right in place. It's a 5-minute plumb job. DIG220 with a warning add salt message or erroneous salt messages. Mrs. Smith calls you up, says, "Hey, I just left your shop. You guys tested my salt at 3,400. I got out here to the AutoPilot, the lights blinking, telling me warning. I had 275 pounds, and my salt reading on the unit is 1,100 parts per million." You need to go out there. The first thing you're going to do when you get there is plug the simulator in. Now, unlike flow, salt is not an instantaneous read. So when you plug the simulator in, you have to give it about a minute to a minute and a half for it to acclimate itself to the tri-sensor simulator. During that time, you should be going to the pool, using your manual check, whether it be salt strips or the Myronel or the Lamont Tracer handheld, some way of checking the salt personally while you're there on the job site. Once you've given it a minute and a half, you're going to go back to the system. You're going to do a test pool pilot, and you're going to see where it's reading the simulator at. If it reads the simulator at 2,200, then your problem is with the tri-sensor. One of 2 things has happened. Either the salt prongs are scaled up, which means you would need to remove the tri-sensor and clean them, or you've got a failed tri-sensor. If the salt doesn't read 2,200 with the simulator in, however, you're going to need to calibrate the system using factory menu. And for that, you're going to need to call the office and one of our customer support reps will be able to walk you through, or should I say myself or your sales rep will also be able to walk you through how to put the unit into factory menu and calibrate using the simulator. Once you've calibrated the unit, you wait for another 1.5 to 2 minutes to make sure the calibration held. And if it did, you plug the tri-sensor back in and the unit should be reading more accurately. If you calibrate the unit and wait a minute, 1.5 minutes and go back in and test it, and you see that the salt has fallen back down to where it was before you calibrated, it means you've got a board issue or a power supply issue and you need to start troubleshooting the power supply. Once again, with the DIG220, that's going to be an 833 board or control board issue or display board issue or a wiring harness. These are the type salts that can be used. You know, in the industry, I know back when I first got started, as you see down there in the corner, we used Morton salt. They didn't actually have bags that were called pool salt or aqua salt. We used to literally go to a Southern States farming supply company and pick up 80-pound bags of Morton salt. But now in the industry, we've got salt that comes in bags that's marked 99% pure salt. That's the salt you want to use. They've removed all the impurities. Any other salt can contain impurities. So salts like your rock salt or the salt for your water softening system, can it be converted to chlorine? It most certainly can, but it also has the potential to stain the pool shell. There was also another chemical they used to add to salt a lot to keep it from caking up, which is called YPS. That's yellow pressurative soda. And that can cause, stain the pool shell yellow. So stick with the 99% pure pool salt. Salt application, you want to add the salt properly. With our system, we do not have any high limit like the other systems. A lot of the other systems, if you're dumping salt in the pool, you have to go shut the pool down before you add the salt, or else you'll shut the system. The system will manually shut itself down as soon as it senses the salt high for 24 hours. With ours, you just dump the salt right in the deep end, brush it towards the main drain, and allow it to get sucked through the filtration system. As I said, once again, we do not have a high limit cutoff, so it doesn't matter how high the system is reading the salt, it's still going to stay working. As far as how much salt to add, you always want to test the water first. All right. Pools that have been around for a long time. If this is a brand new pool job, that's something entirely different. But if you got pools that have been around, been on liquid chlorine for a long time, liquid chlorine is a salt-based chlorine. So it contains salt. I've had customers that's been on liquid chlorine so long that when I tested their salt level in their pool, they were at 2,200 and never had a salt system. It's just going to save you money on the setup, because if you're already at 2,000 parts per million, instead of having to add enough salt to get it from 0 to 3, you only have to add enough salt to take it up from 2,000 to 3,000. You're going to save 2/3 the amount of salt on it. Now, as I once said earlier, I highly recommend that you keep the salt above 3,000 parts per million. Our systems are just going to perform better. The cells are going to last longer. As far as when to add salt, on brand new plaster jobs, on brand new refinishes, you want to follow the plaster manufacturer's recommendation for when to add salt. Mostly what I see is between 28 to 30 days or 4 weeks to 6 weeks sometimes. Just follow their recommendations. Myths about salt. Salt is corrosive. 4 parts per million chlorine is 10 times more corrosive than 4,000 parts per million salt. Most of the damage being done to a swimming pool, like light rings rusting up, face plates and everything else rusting up, handrails rusting up, it's due to the actual chlorine level, not the salt level in the pool. Salt is an alternative sanitizer. Love this one. I don't have a chlorine pool. I got a salt pool. Nope, you have a chlorine pool. Salt is not a sanitizer. We are taking the salt and we're manufacturing chlorine from it. All that liquid bleach that people buy is nothing more than chlorine made from salt water. The same way we're manufacturing chlorine on the side of a house, the people that manufacture liquid chlorine are using salt water to manufacture liquid chlorine. It's only 10% chlorine that they manufacture that way. The other 90% is mostly water. Salt is not compatible with other forms of chemicals or chlorine. That's not true either. We only manufacture chlorine when we have flow. As long as we have flow, we have dilution. So long as we have dilution, we get along with the other pool chemicals. We actually, on our total control system, we actually inject muriatic acid into the manifold before our cell. Now, in the normal world, if you were to take liquid chlorine and pour it together with muriatic acid, you would make mustard gas. But because we are manufacturing chlorine in water and we're injecting the acid into the water instantly dilutes both of them, and therefore they become harmless to each other. Salt level in parts per million. In the pool industry, the average salt system operates somewhere between 2,500 and 3,500 parts per million. The human taste threshold is at 3,500 parts per million. So the only side effect you're going to get from running our systems higher than that is going to be the salt taste is going to be a little bit more prevalent. Now, mind you, the ocean water, as you see down at the bottom, is at 35,000 parts per million. I've had a lot of homeowners be like, ooh, I don't want a salt pool. It's going to taste like the ocean. You're working at salt levels that typical human can't even taste them at. But even if you get higher than the 3,500, the salt taste is going to be about the equivalent to a Gatorade. Human tears in the body is 4,000 to 9,000. That's why a pool that's on a salt system is more conducive to the human body. Contact saline solution is at 6,000 parts per million. That is your corrosion threshold. You do not want to get near 6,000 parts per million. It can become corrosive to handrails, light rings, so on and so forth. And just remember, salt is not an exact science. Even as sophisticated as we are with taking water temperature into the equation of factoring out salt, it's not an exact science. We can be anywhere off between 400 to 600 parts per million. Also, the other reason why I bring this up is because, I get the question all the time, well, I use my handheld meter. I'm always 200 to 300 parts per million off. Don't worry about that. That's, when we're talking about salt differences, I'm talking about salt differences 1,800 or greater. Yeah, not 1,800, but 800 to 1,000 or greater. Bad temp sensor is one of the messages that the DIG220 displays, or if we're talking about erroneous temperature readings, like, Mrs. Smith has got an AquaCal heat pump and it's reading 86, but the AutoPilot's reading 97. Obviously, there's some discrepancy there. Now, do remember, we are downstream of all heat sources. So naturally, if the heater is on, we're going to register higher than what the heater is reading. But, if the heater's off, we shouldn't be reading, 6, 7, 8, 9, 10 degrees higher than what the heater's reading. One of the two of us is off somehow. Now, as far as matching Mrs. Smith's rubber ducky floaty in the pool, I'm not worried about that. One, Mrs. Smith's rubber ducky is floating in the top 6 inches of the water, and that's the warmest part of the water out of the whole body of the pool. We're in the filtration system that's, sucking water from the skimmers, maybe even a vacuum system and or the deep end. But if you have erroneous temperature readings or you're getting the bad temp sensor message, you very simply go out to the job site, plug the simulator in. Once again, temperature is a resistance read, so it's not instantaneous. It's going to take a minute to a minute and a half for it to acclimate itself. So after you plug the simulator in, walk away from the unit, go get something to drink or whatever else have you. Come back, and if the bad temp sensor message is gone, or if you see it reading the simulator at or around 78 degrees Fahrenheit, then there's nothing wrong with the power supply. You've got a bad temp sensor, replace the tri-sensor. All right. If you plug the simulator in and the message does not go away, bad temp sensor, now you've got a power supply issue. You're looking at either a bad 833 board or a bad wiring harness. If you plug the simulator in and it doesn't read the simulator at 78 degrees at, I say at or around because I'm not worried about plus 1 or 2 degrees, minus or plus. I'm worried about, like I said, 6, 7, 8, 10 degrees off. If you see that it's reading the simulator not right, you're going to need to call the factory, get them to walk you through how to put the unit into factory mode and get to factory menu to calibrate the unit. Check cell, clean cell message, or low amp cell question mark message. I put both of these on the same screen because basically one is just a little bit worse than the other. A check cell, clean cell message comes on when the amps of the cell drop to a certain level. A low amp cell question mark message means they've dropped even further. So, if the water temperature is not 75 degrees or 3,000 parts per million salt, expect some variances in the volts and amps. Also, if you're checking volts and amps, you cannot check volts and amps on a cell that's not energized. So the cell always has to be energized whenever performing a test to check for volts and amps. And so putting it in boost mode is the easiest way to do that. Yes, you can turn around and run the percentage up to 100% output. But what happens is if you forget to back it back down from 100% output once you're done, then the system is going to stay at 100% output until somebody realizes that it's been left there. If you put it in boost mode and then when you leave, you forgot to turn boost off, worst case scenario, it's only going to run for 24 hours at 100%. Then it's going to revert right back to the original percentage setting. Salt water is conductive. Cells require salt, water, and electricity to generate chlorine. That's all it takes. Whenever lightning strikes the ocean, it generates chlorine gas. The cell's got to be clean of calcium. With calcium buildup is nothing more than a great big resistor. So any cell that's got calcium buildup between the blades, it is not working properly. And cold water plays a temperature. The warm water is more conductive than cold water. Just a little overview of how the cells operate and clean themselves. And as you can see, the greenish white represents scale buildup that's on the cell. As the cell is manufacturing chlorine and bubbling, the positive ions will leave one cell blade and push the calcium off. And then as those positive ions come in contact with the blade beside it, that's where the reaction takes place. And that's the side that's now manufacturing the chlorine. On top of the chlorine that it's manufacturing, there is a byproduct that's being generated. It's called sodium hydroxide. Sodium hydroxide has a high pH of about 7.8 to 8.0. So it is normal for a cell to get slightly calcified when manufacturing chlorine, like what you saw before I clicked the button that started the automation, that light white film. That's normal inside of a cell when it's manufacturing chlorine. That's also the reason why we have reversal periods. The reversal helps clean that off of there. So when we talk about reversal, what we talk about is you got one blade that's positive, the other one that's negative. The system stops sending current to the cell. Then the one that was positive becomes negative. The one that was negative now becomes positive, and the current travels the other direction through the cell. So on this side of the blade over here that you can't see has that light white calcification that's building up over here. It was here, but the positive charges pushed it off. And now because this one's manufacturing chlorine and sodium hydroxide, it's getting lightly calcified again. This is not a representation of time, mind you. That is not how fast the calcium builds up. This is how the current travels through the cell. Now, in a two-pronged cell, you've got two prongs that the cord plugs down onto. Those prongs, the one prong is connected to the far left blade, the other prong is connected to the far right blade, and when the left blade is getting a positive charge on it, the right blade is getting a negative charge on it, and the current travels from the full, not just in this one area, but the full width of this blade and length of this blade, the positive charges are leaving there, traveling through the water to the next blade, through the water to the next blade, through the water to the next blade, through the water to the next blade. When you guys do a test pool pilot, we've got a built-in multimeter that is monitoring the current that passes through this cell. If anything interrupts the current passing through this cell, the system's going to give you a warning message. Oh, let me take it back here real quick. To discuss with you how three-prong cells work, I don't have a slide, but what you have to picture is, like I said, this would be the left blade, this would be the right blade, or the right prong on the cell, the left prong on the cell, the right prong on the cell, and then there's a center post that the cord plugs out onto. That center cord or center post is plugged or soldered to the middle cell blade. So how this works is when this middle one is positively charged, the outside two are negative charged. So you got the positive charge coming in on the middle blade, it leaves to the left and it leaves to the right, traveling to the outside two blades. When you reverse polarity, and now these two become positive, the far left one and the far right one become positive, and the middle one becomes negative, the current travels from the outside two blades. It'll leave this blade traveling to the center, and it'll leave this blade traveling to the center. That's how the three-prong cells work. There's a 5-step process that is used to troubleshoot volts and amps going to the cell. And this is how it has to be done. And you guys should have seen when you registered that there was a little link to download the volts and amps chart. Hopefully you went to it and you downloaded the volts and amps chart. But it has the 5-step process of getting doing a proper test pool pilot on the back of the chart, where it's giving you different scenarios. But for those, so if you have the chart, flip it over on the back, you'll see these 5 instructions. If the unit's in boost, turn it off of boost. Boost has a memory. Not only does boost remember how long it's been on, it remembers at what current it was sending to the cell. So if it loses power and it comes back on, as soon as the system recognizes it was in boost, it's going to go back into boost. And then it's also going to turn around and look at what the current was that it was sending to the cell before it lost power. So to get a proper test pool pilot done, because we have something in the system called a voltage limiter that will not allow the system to energize a scaled or depleted cell past a certain point. So you've got to do the test before the voltage limiter kicks in. And the only way to do it is follow this 5-step process. Take it out of boost, turn the unit off, power the unit down, in other words. After you power down, you only have to leave it off for about 5 seconds, then power the unit back up. Once the system comes out to the purifier screen where it says purifier and a certain percentage that it's running at, you activate the boost button. After activating the boost button, you'll wait for 20 seconds. I don't care if you count it off in your head, look at your second hand on your watch if you still have a watch, or utilize your cell phone, or the screen flashes. So you can count roughly about 6 flashes will be equivalent to 20 seconds. So 6 flashes of the screen once you've activated the boost button. Once you get to the 20-second mark, you'll hit the menu button, and Test Pool Pilot is the first thing that pops up. You will select Test Pool Pilot. And you'll wait for the volts and amps, or if you're in a hurry, once you get into the Test Pool Pilot, as soon as you see it reading the salt level, you can press the down arrow till you get to volts and amps. And that volt and amp reading that you're getting right then and there is the current that is currently making it through the cell. And based upon your reading, you can utilize that to help you troubleshoot, or where you're supposed to start your troubleshooting. If you have high voltage and low amperage with the test done properly, then you need to start your troubleshooting at the cell and work your way backwards to the power supply. I am not saying that high volts and low amps can't be a power supply issue, but 99.5 to 9% chance that your high voltage and low amperage is going to be somewhere between the cell and the cell cord, especially on a DIG220. All right, if you do it properly and you got low volts and low amps, then you need to troubleshoot the power supply. So on a DIG220, low volts and low amps would mean you could have a bad 833 board, a bad wiring harness, or possibly a bad power module. This is the volts and amps chart on the front side. Basically what I did for you was listed the cells that we carry that can go in the manifold, and that can be run by a DIG220, and then the different power levels that they operate at. All right. So, as you can see, the power levels have the amp levels right below them. Cell power level 1 is 5 amps, cell power level 2 is 6.5 amps, and cell power level 3 is 8 amps. This means that that's the amperage that the system is sending through the cell when the cell is energized. The voltage, however, these were all based upon a brand new cell and salt level at 3,000 parts per million and water temperature above 75 degrees. Your volts are not written in stone. Your amps are programmed into the power supply when you set the power supply up in the installer menu. If you remember when I was showing you the menu overviews, it had set cell power. That's where you're going to go in there and pick power level 1, 2, or 3. All right. So that doesn't change. Voltage, however, can fluctuate. It can fluctuate due to water temperature. Colder water is going to cause the voltage to be higher than what you see on the chart. Warmer water is going to cause the voltage to be lower than what you see on the chart. Age of cell. If the cell is aged, as a cell ages, it's normal to see the volts climb up over time. The voltage will peak out at 32 volts. Once the system is sending 32 volts to the cell, it cannot send any more voltage. So once it peaks out at 32, if there's still a situation, whether it be scaled or depleted or cold water and low salt, whatever the case that may be that is causing the system to jack the voltage up, as soon as it peaks out at 32, then these amps will start to fall. And once these amps get to a certain level, that's when your check cell, clean cell, or your low amp cell question mark messages come out. All right, so check cell, clean cell messages, if you've got high volts and low amps, you need to analyze the cell for scale buildup. You need to inspect for visual depletion of the cell blades. I got a slide that I'm going to go over that with you. You need to check for improper voltage. Now, improper voltage would be low, if you had low volts and low amps doing the test pool pilot with one of these messages. And then, you want to inspect the cell cord to see if the plugs burn up or the plugs that go up underneath and plug into the bottom of the power supply are burn or discolored. If you got low volts and low amps, you could have a power module issue. If you have the cell cord burn up, typically the cell cord burn up is due to loose connections. Loose connections can happen over time via, if somebody's really aggressive, unplugging the cell cord, like using a pair of channel locks or something, or they're grabbing the cell cord and pulling up on it. And instead of, the handle on the cell cord, the plug part actually has little grip moldings on it, so you can grip it firmly with your hand, and you should pull straight up on it. If you're wiggling it back and forth, especially aggressively, the connectors inside the cell cord plug, they're not a complete circle, so they have a little small slit that runs down the complete length of them. So, and there's a black substance that surrounds the copper brass that is a little bit pliable, so you can actually cause the connector to spread out, open and widen up. And once you have a gap between electrical contact points, just like your spark plug in your car, it will start arcing. Once it starts arcing, it builds up heat, and that's the black stuff that's around the copper brass connectors is actually our early warning system. It has a low heat threshold. That black stuff will actually melt and run down out of a cell cord. So if you've ever seen a cell cord that has black oozy stuff coming out of it, it means that cell cord's overheating and you need to replace it. Water and moisture damage, most of the time it's due to cells being installed upside down where rainwater has been allowed to enter into the cell cord. And then a cord not fully seated. Once again, if it's not fully seated, you're creating a gap between an electrical contact point. And I've already said, pull straight up on the plug. Scaled cell, check cell, clean cell message or low amp cell question mark message. You do the test pool pilot and you're coming back with high volts and low amps. First thing I want you to do is remove the cell. Take a look and see if the cell's scaled up. If the cell is scaled up, I promise you, the current's not going to pass through that. That cell that's pictured there, that's nothing more than a great big resistor. Current cannot pass through the calcium. So it's going to interfere with the current passing through the cell, and you're going to wind up with a message. White flakes back to a pool. I receive probably at least 50 calls a year on this. All right. White flakes back to the pool are a good sign to me. The reason why, if you take a look at that cell that's pictured, the only reason why that calcium is going to leave those cell blades if my system is reversing polarity and pushing it off of there. So if you're getting white flakes back to the pool, it means that my system is reversing polarity and it's cleaning itself. The reason why you're seeing them back in the pool is basically because the water is saturated to the point it says, hey, I got rid of this stuff for a reason. I can't hold it anymore. So you need to be looking at your water chemistry. You need to run the saturation index. It says inspect the cell for excessive wear. That's what this next slide is covering. If you got a scaled cell, you need to clean it up before you can even look at the outer edges of the cell blades. If you get to a job site and you're getting a check cell, clean cell message, low amp cell question mark message, and you run the test pool pilot and you have high volts and low amps, and the cell is clear of calcification, you need to be looking at the far left and far right blade if it is a two-pronged cell, or you need to be looking at the far left, right, and center blades if it's a three-pronged cell. I've got a question that's coming in. Go ahead, Matthew.
Okay, Brad, we actually had two questions. One was about salt that we've kind of already answered in the chat feature, but
I can answer that one.
Yeah, that question was, is it possible to use other types of salt? And the answer to that one is any type of salt will actually work and produce chlorine, any type of regular salt. But the problem is salt that is not food grade can have impurities in it. It can have metals in it. And those impurities and metals can stain the water and or the surface of the pool. So that's why we have to use food grade salt.
I've literally seen a homeowner that used rock salt, and then he used rock salt because he was low and his chlorine was low in his pool. So he activated the boost button, and then the water literally had like a black tinge to it coming out of the returns, and then eventually his whole pool had a black tinge to it because basically the cell was rusting the iron and burning the iron up that was in the water.
Yeah. So there's a lot of impurities. That's really the only reason. Any type of salt will create chlorine. So the other question we had is, what causes those calcium nodes or buildup on the bottom of a concrete finish pool, a diamond bright or a similar finish? You get those little calcium lumps.
Yeah. Okay, it's just basically, where the calcium or it's your water that's out of balance. And, you almost got to look at water like a living creature. It wants to be happy. So water has basically three forms. It's either acidic or alkaline, it's neutral, or it's scale forming. All right. So to find that out, you actually have to run the saturation index. And I highly suggest if you have questions on water chemistry that you join us for our water chemistry seminar that we have coming up, because there's a big huge misconception as far as water being good because everything was within industry standards. When you get outside of when you run the saturation index, that's how you tell whether your water is balanced or not, whether it's alkaline, neutral, or scale forming. And basically, if you've got a pool that's got buildup, calcium deposits on the shell, it means that you're running high on the saturation index.
Okay, thank you, Brad.
Now, I see that they're mentioning something about having 2 autopilots on it. As I said, remember, any salt system, not just our salt system, but any salt system has a byproduct of sodium hydroxide, which has a high pH of, like I said, 7.8 to 8.0. So as the salt systems are on generating chlorine, it's also generating the byproduct, which is raising the pH in the pool. pH is probably the #1 thing that causes a pool to be scale forming. The higher the pH goes, the worse it gets.
Brad, that question about the 2 autopilots, Roberto's asking, they've got 2 systems on the same pool.
Yeah.
And one is showing a salt level of 3,500 and the other 2,500. So they're out of calibration significantly. And he's asking how to handle that.
Yeah. Once again, for any erroneous salt readings, because in this situation, it's hard to tell which one's right. Is it the higher one or is it the lower one? You would need to use the simulator to determine that. So by plugging the simulator in, you would wait the 1.5 minutes for it to acclimate itself to the simulator, and then you would do a test and see what it's reading the simulator at.
Okay, and you mentioned the part number earlier for that simulator.
Yes, the part number for that simulator is a 986-ST.
Okay, and that simulator is just a very simple diagnostic tool. And if you want one of those, just contact your sales rep and they can arrange to get it for you.
Yes. Before we started taking questions, we were talking about scaled cells and how to troubleshoot a check cell, clean cell, or low amp cell ? Message. Once again, I revert back to running the test properly, and when you ran the test, whether you got high volts and low amps or low volts and low amps. High volts and low amps, you're going to always start your troubleshooting at the cell. So, we talked about checking the cell to see if it's scaled up. We talked about white flakes back to the pool. We talked about if the cell's not scaled up, but you're getting those messages, to check the blades, the far left, the far right. If it's a 2-prong cell, or if it's a 3-prong cell, check the far left, far right, and the middle blade. Because in a 3-prong cell, the PPC4 has 13 blades, and a PPC5, it has 15 blades. Once again, you get far left, far right, and the middle on the PPC4 and PPC5. When a cell is depleted or partially depleted, what you will typically see is that the left and right blades are thinner and shorter than the ones in between them. Or on a 3-prong cell, you'll see that the left blade, the right blade, and the center blade are thinner and shorter than the ones around them. If a cell is scaled up, you can't check the leading edges. You need to clean it up first. You need to plug one into the cell off, fill it full of water acid solution. Now it says 4-to-1 ratio. That's mainly for homeowner safety. For you guys out there in the industry that are already messing around with the muriatic acid on a daily basis, you can cut that back to a 1-to-1 ratio or a 2-to-1 ratio. Muriatic acid has no effect on ruthenium. So for a one-time cleaning, trust me, I've seen cells that if you used a 4-to-1 mix, you'd be there for an hour and a half trying to remove the calcification. So you can strengthen the mix, plug the end of the cell off, add a little bit of water. And remember, it is always acid to water, not water to acid. If you add water to acid, it's going to bubble and spit at you. You're going to get a chemical reaction. So add the acid to the water. Soak the cell for 15 to 20 minutes or until there's no reaction. If there's calcium present inside a cell, you're going to get bubbling as a reaction. So you're going to wait till it stops bubbling. Once it's stopped bubbling, one of two things has happened. Either all the calcium has been eaten away, or the acid is so saturated with calcium, it can't absorb anymore. So once it stops bubbling, you'll dump the solution out. You'll check the cell to make sure you got rid of all the calcium. If not, you're just going to repeat the process till it stops bubbling and there's no more calcium buildup. And if And if you check it and there's no calcium buildup, the other thing you're going to look for, like I said, is excessive wear on the blades. If you don't see any wear on the blades and it was scaled up, you're going to put the cell back in line. You're going to run it in a boost cycle, and you're going to see what your volts and amps are after about 20 to 30 seconds of operation. Hopefully your message has gone away, and the only thing that was wrong with it is that it was scaled up. Once again, this is just talking about the excessive wear on the blades when cells deplete. Is the unit producing? If your volts and amps are in the ranges that they're supposed to be in, and typically there's really no range for volts. I mean, volts is peaked out at 32. The power supply is going to drive the voltage however it needs to meet the amp level desired. Like I said, the amp level is controlled by what power level you set it at. So the system is going to drive the voltage however it needs to make sure or ensure that the system is reaching the amp level it's set for. By increasing the salt and by having the water temperatures higher, you can actually get the voltage to decrease, so long as everything else is good. The great thing about decreased voltage means you got less current passing through the cell. Less current passing through the cell means the cell will last longer. Once again, that's all, just by running your system with a higher salt level, you can get a longer cell life, not only because you're manufacturing more chlorine per minute, but also because you're sending less current through the cell. Water conditions, load factors, chlorine demand is what I like to call it. All right. I handle probably 200 to 250 cases a year of a unit that is, by all intent and purposes, reading perfectly fine, but there's no chlorine in the pool. So naturally, because the homeowner has a salt system and there's no chlorine in the pool, the finger gets pointed at the salt system. If you want to know whether the system's working or not, take that same plug that you use to clean the cell, which you can use an 1.5-inch drain out, clean out plug to clean the cell. Or if you want, you can contact your sales rep and he can get you a cell cleaning plug. It's a cell cleaning cap that, the unions screw right down on it. So what you would do is you need to carry a depleted cell on your truck, like an old cell that you've already replaced for a homeowner because it was depleted. Or you can once again get in touch with your sales rep. We actually make what we call spacer cells that have no blades inside of them. You can use a spacer cell or a depleted cell or even a new cell, because the only thing you're going to use it for is to take the place of the cell that you took out of line. So you'll put the cell in line that you brought with you. You'll take their cell out of line, leaving the cell cord hooked up to it. You'll plug the bottom of their cell off with an 1.5-inch drain out, clean out plug or one of our cleaning caps. You'll fill it full of the pool water, and then you'll activate the boost mode. And within a matter of a few seconds, the cell should start bubbling like Alka-Seltzer. And then you can prove to the homeowner that the system is manufacturing chlorine. Because if it'll manufacture it in a boost mode, I can assure you that it's manufacturing it under the normal percentage of output mode. Now, I have had homeowners ask me, well, how do I know that those bubbles are chlorine? Well, hold it under their nose for about 4 to 5 seconds. They'll start to tear up and cry. And then y'all can move past the fact that it's, are those bubbles chlorine or not? Oh, let me take it back to this. I just want to, touch on a little bit of the water chemistry here. Phosphates and nitrates are a big culprit as far as no chlorine in the pool when the system's manufacturing chlorine perfectly. Pump run time. There are a bunch of different factors that come into play. Just because there's no chlorine in the pool does not mean that the unit is not manufacturing chlorine. And you can talk to a homeowner all you want to about volts and amps. Like, ma'am, I did the test pool pilot. You're at perfect volts and perfect amps. We know that means that the cell is manufacturing chlorine, but when there's none in the pool, seeing is believing to a homeowner. So like I said, this is the easiest way to show them that their unit is manufacturing chlorine. Blank display. If you have a blank display on a DIG220, it could be in sleep mode. Now, I will say that the DIG220 does have a little dot that bounces around the screen when it's in sleep mode, but sometimes you can't really see that versus a full lit up screen. So if it's in sleep mode, the only thing you have to do is push a button to bring it out of sleep mode. How sleep mode works is, 30 minutes after the unit powers up, if nobody hits anything on, nobody presses a button on the unit, it will go into sleep mode, and it'll stay asleep until somebody pushes a button or it loses power and then powers back up again. The other thing you want to check with no display is you want to check the incoming power. The breaker could be off. You could have a bad leg on a breaker. If it's a 220 breaker, you could have one leg that's working and one leg that's not. Wrong incoming voltage. That could cause the display to go out and then it not wake up from sleep mode. Blown power fuse or blown display fuse. Loose or damaged wiring harness, or potentially a bad display board. So main things in the DIG220: incoming voltage, sleep mode, fuses, and wiring harness or display board. This is the parts breakdown list for the DIG220. All right. I do highly recommend we carry this parts breakdown catalog online at AutoPilot.com. If you go to AutoPilot.com and you click on either service, I think it comes up on just about any of the regular links, even products. But you'll click on, you can click on service, then scroll down through the service till you find all the little blue hyperlinks that come up. And then you can find it'll say parts breakdown catalog. If you click onto that, you can download it to your PC, or if you have a smartphone that has a books app, you can download it to it. It is a PDF file. Having part numbers is great, but people's terminology is different. So when you have a catalog that has pictures are worth 1,000 words. It's hard to get it wrong when you have a part number with a picture beside it, so you know exactly what you're talking about and what you're ordering. And the same thing with the person that's on the line taking your order. Looks like we have another question. Something about the battery, Matthew?
Yes, Brad. Sherilyn's asking if the 2032 battery in the DIG220, does it hold any of the information for the display?
No, the only thing that battery is used for is because, unless the DIG220 is running the pool pump, it's more than likely going to be wired to a time clock. So it's going to go off when the pump goes off. The battery is solely used so the system will keep time. The memory and programming is held on the microprocessor, so it's a hard memory. It doesn't lose memory when the power's off. The only thing that will lose anything if that battery is dead is the time, which means if that battery's dead, every time the system loses power, it's going to revert back to 12 a.m. till it loses power again.
Okay, so the 2032 refers to the actual size or the model of the battery.
That is correct.
Yeah, and all that does is hold the date and time. Does it also hold the pump programming?
Pump programming is held on the microprocessor.
Okay, so just the date and time. Perfect.
Yep.
Thank you.
Yep. Not a problem. All right, so once again, we just got done discussing where you can find the parts breakdown catalog. If you're having trouble finding that, you can contact your sales rep. You can contact our customer support hotline. Once again, these are our webinars that are coming up. The 75003 Next, CoPilot, Soft Touch, Pool Pilot Professional, ORP, Total Control, and Water Chemistry. The additional factory resources, like I said, tech support. If you need help, with anything, you can contact that parts breakdown catalog as well. Contact them. They'll walk you through exactly where to find it and how to install it onto your computer or your smartphone. And then again, just want to mention our YouTube videos. This is a growing library, so we're not done adding to this. We've just recently started, but you'll see more and more videos coming along as we go. I want to thank you guys for attending, and I'm going to go ahead and open this up for questions. Please, your input on this training is imperative for approval. So if you have any inputs on it, any comments at all, I greatly look forward to them. And last but not least, this product is made in the United States, right in St. Pete, Florida. Matthew, I'm going to go ahead and open it up to questions. So once again, anybody, if you have any questions, use your question and answer bar.
Or the chat feature, either one is fine.
Or the chat feature, that is correct.
All right, well, I don't see any more questions. I guess we've answered them as we've gone along. And for my part, I hope to see everybody next Tuesday for our next seminar, which is on the, is that the 75003/total control, Brad?
That is correct.
Okay.
All right, well, Matthew and myself will be monitoring for a little while longer in case it looks like we have something on life expectancy.
So yeah, it looks like Roberto's asking, is the life expectancy of a cell, we're assuming of a cell, more than 2 years?
Life expectancy, we discussed that earlier. Time-wise, there is no life expectancy on a cell. All right. As I told you earlier, the life of a cell is kind of like a battery. It all depends on how long and how hard you use it. Now, I will tell you that we do have a chart, and you could probably get with marketing, Matthew, if I'm not mistaken. And basically, the chart shows that if you have a PPC1 cell, so long as the salt stays at 3,000 and it's not running cold water temperatures and it doesn't ever get scaled up, the cell will manufacture roughly about 200 gallons of chlorine in its lifetime. It's basically a comparison chart for how to show homeowners that it's actually less expensive to buy a cell than it is to continue to buy whatever type of chlorine that they're buying on the market to keep their pool sanitized. But it gives in reference how many gallons that cell will manufacture in its lifetime. How fast you achieve that, that gallons of output, it depends on how long you run the cell, at what cell power you run the cell, at what salt level you run the cell at what water temperature you run the cell at, whether the cell ever gets scaled up or not, whether you're trying to utilize the cell to compensate for a heavy phosphate load, how many times you put it into, there's so many factors that come into play, but mathematically, let's take a PPC1 cell that manufactures 200 gallons of chlorine in its lifetime, so long as it's run properly. Now, I will tell you, if you run it at higher salt levels, it will actually manufacture more than 200 gallons in its lifetime. The numbers I'm talking about were based upon 3,000 parts per million salt. But let's just take what it was tested at. 200 gallons of chlorine in its lifetime. If I've got a pool that's operating 24 hours a day, and I put the DIG220 at cell power level 3, which is 8 amps, which then means I can run that cell at 100% output at 8 amps and manufacture just over 1.25 gallons of chlorine per day. How many days is it going to take me to wear out 200 gallons? I'm manufacturing over 1.25 gallons a day. So I'm going to wear that cell out in less than 200 days. Actually, probably right around 175 days. So once again, you can't, as far as, it's hard to put a amount of time on a cell. My in-laws, they had a 12, 13,000 gallon pool. They had the equivalent to a PPC1. It wasn't named a PPC1 when it was installed, but it is a 5-blade cell, which is the equivalent to a PPC1. Once again, on a 12 to 13,000 gallon pool, their cell lasted them 9.5 years, and they're here in Florida.
Hey, Brad,
Yes.
would you agree with the comment that the way the majority of the dealers size this cell, as long as they are, there isn't any unusually high chlorine demand and the water balance and salt are maintained, that most cells we see are lasting about 3 to 5 years?
Oh yeah, so long as they're run properly, and on the right size or proper size, can't do anything about heavy bather load pools or heavy chlorine demand pools. But on a normal pool, normal residential pool, run properly, the cell should, yes, most definitely last you 3 to 5 years. Once again, I do want to reiterate, if you want longer cell life, run the pool with a higher salt level and keep your water chemistry in balance.
And I would add to that, Brad, and let me know if you agree that that would hold true for any salt system.
Any salt system, except, well, the higher salt, you need to follow the recommendations of the salt system, that, you know, because there are systems out there that will shut off if you get the salt too high. But any salt system will perform better at higher salt levels, you know, and once again, some of them are limited to what they can handle. You don't want to get above that. But with our salt system, we have no high limit. You just don't want to get close to 6,000 parts per million. I typically say run them between 4,000 and 4,500. The side effect you're going to get from that is the salt taste is going to be a little bit more prevalent.
All right.
Any questions? We're all good now?
I think we're good.
All right, awesome. Well, once again, thank everybody for your time. You know, I know to take 2 hours out of your day to attend something like this is, you know, it's kind of hard, especially this time of year, and I greatly appreciate it.